Our last lesson in Chapter 7 is going to focus on problem solving. So let's go ahead and take a look at some word problems, and then you're going to identify what am I doing in this word problem. Specifically with this chapter, we're adding and subtracting fractions or mixed numbers. So am I adding, am I subtracting, what am I trying to find out? Let's go ahead and take a look at our first problem. So last week, Asa ran 3/4 miles each day for 5 days. He then rested for 2 days. Did Asa run 6 miles last week? Explain. How would we solve this problem? What are you going to do with the information you have? And then, did Asa actually run 6 miles last week? Go ahead and solve this problem now. So we all know that there are 7 days in a week. And so for 5 of those days, Asa ran 3/4 of a mile. So I wrote out our Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, our days of the week. And he ran 3/4 of a mile for 5 days. So I went ahead, and it doesn't matter what 5 days you choose, but 3/4 of a mile, Monday through Friday, and then he rested for 2 days. So we want to know, did he run 6 miles last week? Well, first we need to figure out what our total amount that Asa ran is. In order for us to do that, we have all of these 3/4, and all we need to do is add them together. So add all of your 3/4 together, and then what are you left with? We're left with 15/4, and we want to know if he ran 6 miles. So we need to take our 15/4, because right now it's a fraction greater than 1, and we need to turn it into a mixed number so that we can see if he ran at least 6 miles last week. So in order to turn it into a mixed number, we can either divide or we can pull out our wholes. If we're dividing, 4 goes into 15 3 times, and then we have 4 times 3 gives us 12, so we would have 3 left. So Asa ran 3 3/4 miles last week. Did he run 6 miles? No, he did not. So the answer to this question would be no. Asa only ran 3 3/4 miles. He did not run 6 miles last week. Let's take a look at our next question. A quarter is 1/4 of a dollar. Mia has 20 quarters. How much money does she have? Go ahead and solve this problem. How much money does Mia have? In order to solve this problem, we could have 1/4, and we can write 1/4 20 times. If we wrote 1/4 20 times and then added them all up, because we do have a unit fraction, 1/4 20 times would give us 20/4. Now this is a fraction greater than 1, and I want to know how much money she has. And this isn't a really good example of how much money she has. I don't really have a good idea. So I need to change this into a mixed number. So I'm going to go ahead and I'm going to pull out my wholes. So when I pull out my wholes, I end up with 5 4/4. And since each of these 4/4 are equivalent to 1 whole, in this case 1 whole dollar, Mia has 5 whole dollars. So we needed to figure out how many total quarters she has. She has 20. Put that over our denominator of 4, and then convert it into a mixed number, or in this case, a whole number. Here's our next problem. How many 2/5 parts are in 2 wholes? It might help if you draw a picture for this. We want 2/5, and then we're dealing with 2 wholes. So I would separate your wholes into 5 parts to identify how many 2/5 parts are in 2 wholes. If I want to figure out how many 2/5 parts are in 2 wholes, I'm going to draw a picture. And my wholes are going to be split into 5 equal sections because I'm dealing with a 5 in my denominator. And I would color in 2 sections for each color. So there's 1 2/5, there's 2 2/5, 3 2/5, 4 2/5, and then I'm left with 5 2/5. So a picture really helps me solve this problem. If I want to know how many 2/5 parts are in 5 wholes, I know that there are 1, 2, 3, 4, 5. So 5 2/5 parts. Another way that you can solve this problem is to think about, well, how many parts are in a whole? In this case, there would be 5/5 parts in a whole, and we would have 2 of them. So we would have a total of 10 parts. And then if I want 2 of those parts and 2/5 parts, I need to think how many 2/5 can I add together to equal my 10/5. And I would need 5 of my 2/5. And when I added all these ones up, I would get 10/5. So you have two separate ways that you can do this. You could either draw a picture, or you could think about what those two holes would look like. Let's look at our next problem. Heidi painted 4/12 of a mug red and 5/12 of the mug blue. How much of the mug was not painted? Think about what represents a hole and then identify how much of the mug was not painted. Well, we need to figure out what one hole of her mug would be. So we have her mug, and she's painting her mug. And notice how our denominator is 12. So that means our mug is divided into 12 equal parts. If she paints 4/12 of it red, and then she paints 5/12 of it blue, and I want to know how much is not painted, again, a picture here is very helpful for me to figure that out, and I would be able to see that 3/12 of her mug is not painted. I could also do some math, so I need to figure out how much is not painted. In order for me to do that, I should figure out how much is painted. So I could take my 4/12 and my 5/12 and add them together, and if I have 4/12 plus 5/12, I'm going to get 9/12. And then if one hole is equivalent to 12/12, I can subtract my part that's painted, and I'm left with 3/12. So either way, drawing a picture or doing some math, we're still going to end up with 3/12. Pictures are always a great option when we're dealing with our word problems, especially when we're dealing with fractions. All right, so that's that problem. Let's go ahead and look at two more problems. There were 8 apples in the refrigerator. Carson and her friend ate 4 2/5 of the apples. How many apples are left? Go ahead and solve this problem. Because I want to identify how many are left, and they're eating 4 2/5 of the apples, I'm going to have to do some subtraction. So I have my 8 wholes minus my 4 2/5. Now before I can subtract, you'll notice that we don't have a fraction here. And because there's a fraction in my number on the bottom of my subtraction problem, I need to have a fraction on top, because remember, we always subtract our fractions first before we subtract our whole numbers. Well, there's no fraction here in the top number in order for me to subtract, so I need to create one, which means I need to borrow from my whole, and my 8 would become a 7, and then I need to add a whole as a fraction. I have to look at my denominator for the fraction on the bottom, and it's a 5, so that tells me my whole is going to be equivalent to 5/5, and now I can subtract. 5/5 minus 2/5 gives me 3/5, and 7 minus 4 gives me 3. So Carson has 3 3/5 apples left. Remember, when you're subtracting and when you're adding, we add or subtract our fractions first, and then we add our whole numbers. If there's not a fraction there to subtract on the larger number, then we need to create a fraction by borrowing a whole and then creating a whole as a fraction. All right, one last problem for us today. Haley was baking muffins for a party. The blueberry muffin recipe called for or required 2 1/4 cups of flour, and the banana muffins recipe required 1 3/4 cup of flour. Haley had 6 cups of flour. How much flour will she have left after baking the muffins? All right, so this is a multi-step problem. Figure out what you're going to do in order to figure out how much flour she used and then how much flour she has left. She's baking 2 different types of muffins which require 2 different amounts of flour. So we have our 2 1/4 cup is what she's going to use for the blueberry muffins, and she's going to use 1 3/4 cup of flour for the banana muffins. I need to figure out how much flour she uses. In order to do that, I have to add. So 2 1/4 plus 1 3/4. I'm going to add my fractions first, and I'm going to add my whole numbers. And then I notice that my fraction here is equal to or greater than 1 whole, or it's greater than a whole fraction. So this is equal to 1, and because this is equal to 1, I need to add it to my whole number. So she uses 4 cups of flour. My problem also tells me that Haley had 6 cups of flour to start with, and I want to know how much she's going to have left after her baking. So this 6 cups is important because that's how much she's starting with. Now that I know how much she used, I have to go back to that information. So she had 6 cups. She used 4 cups. How many cups of flour does she have left? 2. So we have 2 cups of flour left. Okay? When we're solving these problems, it's really important that we identify what's going on in the word problem. Make sure you're looking at the word problem, thinking about the word problem. Am I adding? Am I subtracting? Do I have to do some regrouping? Draw a picture if it helps, and then solve that problem. That's our lesson for today. See you tomorrow when we do some review.